Okay, hello everyone. Welcome to our trigonometry. I love trigonometry. The easy stuff, not the harder stuff. So we are done with chapter 1, 2, 3, and we have chapter 4, the entire chapter 4, and then only 2 sections of chapter 5. So hopefully we will be able to finish everything. We have 3 days, 2 weeks, right? 3 days and 1 more week, or 2 weeks. I forgot. I will not count all the days. So, wow, great. Then you'll be able to finish our syllabus in no time. And you'll be ready for the final exam, hopefully. But remember, the last Monday, so we have how many more Mondays? 2 more Mondays? Chapter 1, chapter 2. Yeah, we have 2 more Mondays, right? And then the 29 is 1 Monday. We have 2 more Mondays. So the last Monday, July 6th, is all the homework. Like whatever you have, on our website, everything you must do by Monday, Tuesday, Wednesday, Monday midnight. Okay. So before that, if you miss any chapter, any section or anything, I don't mind opening them. But after July 5th, 6th, after July 6th, I'm not going to open anything, no matter how much you beg me. Okay, I'm warning you guys. So whatever you do, make sure you complete all the homework by Monday, July 6th, midnight. Our final exam will be July 9th, and I'm planning to spend at least 2 days on reviewing. If not possible, then at least 1 day on reviewing. And we have 1, 2, 3, 4, 5, 6, 7. 7 classes, including today, before your next exam, right? Yeah. Actually, time-wise. Wonderful. Okay, so we are going to start chapter 4. Any question? Comments? Concerns? Okay. What do you mean? Mm-hmm.
And I double checked, triple checked. And finally, I just like cross-referenced it with like that AI thing, and that was the answer, but some reason
You didn't accept the answer? Okay, so when you ask me any question, I don't receive any notification. So I actually have to log in into a website to see if you send me anything. So I'll do that. And then check. Yeah. Mm-hmm. Yeah, website, it's very sensitive. You have to enter exactly how they want you to enter the answer.
So sometimes those two
Mm-hmm.
questions are similar.
It doesn't work. Yeah, I'll log into our website and then see what issue you have. So yeah, anytime you need my help, send me an email. I may not get it until I log into our website, but when I log in, I'll take a look at that. Okay, so we are going to cover each section of chapter 5, chapter 4, and then the most important topics. What usually comes in the final exam are all these things. And now we are going to start by little background of trigonometry. So as derived from the Greek language, the word trigonometry means measurement of triangles. Interesting. Trigonometry. Originally, trigonometry dealt with relationship among sides and angles of the triangles and was instrumental in the development of astronomy, navigation, and surveying. With the development of calculus and the physical sciences in the 17th century, a different perspective arose. One of the viewed the classic trigonometry relationship as functions with the set of real numbers as their domain. Consequently, the applications of trigonometry expanded to include a vast number of physical phenomena, such as sound waves, planetary orbits, vibrating strings, pendulums, and orbits of atomic particles. In other words, we use trigonometry in many um, places in our life. Okay, so we are going to start by defining an angle. We all know what is an angle, right? The angle. So the angle is union of two rays having common endpoints. Anytime you have rays means a part of line. So anytime you have two lines, they are meeting at some common endpoint, you get an angle. For example, if this is a line and this is another line, there is angle here. There is also angle here. There is also angle here. There is also angle there. So anytime the endpoint of two lines gives us an angle. Usually we write angle this way. Now angle has an initial side and a terminal side. Initial side means where you're starting your angle. That side, for example, here in our XY plane, this is 0 degree, this is 90 degree, because we have exactly 90 degree angle between the two lines. And there's also another 90 degree. That means we reached 180 degree here. And there's also another 90 degree here. That means this is 270 degree. Now, what you always start, I should actually make a good blank page. So quadrant plane, x-axis, y-axis, x, y. Here we have 0 degree because there is no degree there. We have a 90 degree here. That means this one turns into a 90 degree. There is another 90 degree here between these two lines. So if you have another 90 degree with the previous 90 degree, this is 180. There is also another 90 degree here. So it's 270 degree. And there is another 90 degree here. So if you count here, this turns into 360 degree. When you start an angle, you always have to start on the right side of the x-axis. Most of the time, if you're working on XY plane. So this side where you're starting your angle is called initial side. Initial means something you're starting, initial. And it doesn't matter where you're stopping. If you stop here, then we have an angle between the initial side and the end. This end is called terminal side. In a terminal means end. So terminal side, it's the end of your angle. So every angle has an initial side and terminal side. Now, if you don't draw an angle on the XY plane, but you just randomly draw an angle, for example, like this, well, still, this is your initial side, and this is your terminal side, because the angle you have between them is here, or you may say this is your angle. Angle could be anywhere you want, but anytime you're starting, that's initial, and while you're ending, that's terminal. And in standard position, we always start our angle from positive x-axis, like here on the right side. And the end point where the two ray or two portion of the line meet, this is called vertex. So here, this point is called vertex. every time the standard motion for angle is counterclockwise. So it always starts from the bottom and it goes upward. If you go this way, then your angles will be positive. If you go counterclockwise, you're having a positive angle. It doesn't matter where you go, as long as you walk counterclockwise, all the angle you have, all of them will be positive. But if you want to go clockwise, then you may have same angle, but this time your angles will be negative. So clockwise gives us negative angle. For example, here to here, maybe positive 45 degree, because it looks like middle of 0 and 90 degree. Now, if you draw an angle here on the bottom, so your initial side is x-axis always, and your terminal side is here. So this angle is also 45, but this is negative 45 degrees. So from the positive x-axis, if you move upward, your angles are positive. From the positive x-axis, if you move downward, your angles are negative. The standard angles are positive, and non-standard or any type of angle could be negative, could be positive. Okay. Now, for every angle, we may find some reference angle. Reference angle for any angle in standard position, reference angle is an acute angle. Acute means it's less than 90 degree with the x-axis. For example, can I make it bigger? A little bit. So if you draw an angle, actually, let me go to page and do it there. So if you draw an angle on the first quadrant, you know quadrant, right? This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. You know this, right? On the XY plane? Okay. So if you have an angle on the first quadrant, all these angles in the first quadrant are less than 90 degree. So this angle have reference angle themselves. So the original angle and the reference angle are same. So reference angle is the angle between the x-axis and the terminal side of your angle. So this is the terminal side of our angle, and this is our x-axis, the original axis, and the reference. The original angle and the reference angle are same in the first quadrant because all the angles are less than 90 degrees there. Now, if you have an angle on the second quadrant, reference angle is the angle that shares the terminal side of your given angle and the x-axis. So the green one is the original angle, and if you want to find its reference angle, it has to share the terminal sides and then the axis.
So it's the same.
So every angle in the first quadrant is same as the reference angle. Or the other way around. The reference angle for every angle in the first quadrant are same. Any angle we have in the first quadrant, they have the same reference angle. The reference angle doesn't change. Where is the oh, that's right. Red or green, whichever. One of them is original, one of them is reference. Let me explain the other scenarios, then it will be clearer to you. Let's say we have an angle here on the second quadrant. So this is our initial side. We started our journey from 0 degree and we moved all the way here. So these two lines gives us the red angle. Now if you want to find the reference angle shares the same terminal side and it also has to touch the x-axis, and it has to be less than 90 degrees. So the only way you can draw a reference angle for my angle is using the terminal side and the negative part of the x-axis. So this is our reference angle. Reference angles are the angles which share the same terminal side as the original angle, and it also has to have x-axis on it. So one side must be x-axis, the other side has to be the terminal side of the original angle. And it has to be less than 90 degrees. More than 90 degrees, then you have a different angle, different reference angle. So we have a reference angle here. This is reference, and let's say this is our original angle. Let's represent by theta. Theta is the original angle, then its reference angle will be the tiny piece on the second quadrant. For example, if this is 180 degree, can you guess what will be the reference angle? This tiny angle. 180 minus our 150 degree, which is 30 degree. 30 degree is less than 90 degree, so it satisfies. Reference angle has three conditions. It has to touch the x-axis. Positive or negative, it doesn't matter which x-axis, but it has to touch the x-axis. It has to touch the terminal side of your angle, whatever angle you have, the terminal side, it has to be in the reference angle. And also the angle you have, it must be less than 90 degrees.
So why don't you subtract 150 from 180? Just take a guess.
No, I said, let's say my original angle is 150 degrees.
Oh, 180.
Sorry, 150, my bad. Let's say the original angle is 150 degrees. That means the reference angle is x-axis, which is 180, minus my terminal side, which is 150. So we have 30 degree in the second quadrant. Three conditions. It has to touch the x-axis. Positive x-axis or negative x-axis, it doesn't matter. It has to touch the x-axis. And then it has to touch the terminal side of your angle. Whatever angle you have, the terminal side must be one side of the reference angle. And at the x-axis and the terminal side, whatever angle they make, the angle has to be less than 90 degrees. The ending. No, always in the x-axis. The standard angle always start from the positive x-axis. But if you don't use axis, if you just normally draw a graph, an angle, for example here, now you have to decide which one is your initial, which one is your ending. For example, this may be my initial, this may be my terminal. Or this could be the initial, this could be terminal. I don't know because this is not a standard angle. It's just an angle somewhere lying. But standard angle has to start from the positive x-axis. And then wherever you go, it doesn't matter. It depends on your angle. Okay, now let's say I have an angle. I'm starting from my 0 degree and I'm ending on the third quadrant. 250, let's say. Suppose this is 250 degree. Now, how can we draw an angle? So our reference angle must touch this ending, the terminal side, and also x-axis. Which x-axis, positive or negative? Great. It has to be here. This is the shorthand. If it's less than 90 degrees, the reference angle are same. If it's between 180 to 90, it's 180 minus 11.
Oh, no, there's no symbol in that.
Or reference angle? No. We just call it reference angle. I'm using R here, but they don't have anything. Okay, so can you find out how much is our reference angle? 250 minus 180. How much that would be? 80, 70. So this is 70 degree. And then if you have a reference angle on the fourth quadrant, so if you start from the positive angle, positive side, and move positive direction, and let's say you're ending here. So let's say this is 270, 290. Suppose my original angle is 290. Starting from the 0 degree, you are walking all the way to the fourth quadrant. We have a 290 degree angle. So for this 290 degree angle, where our reference angle will be? Positive x-axis. So this green is our reference angle. And how can you find out how much is that? But we don't know how much you have to subtract from 360. Oh, 290. Yeah. So 360 minus 290. How much you get? No, 360 is, it has to be, reference angles are always positive. Oh, I forgot to mention the fourth condition. There is another condition for reference angle. They always are positive. Yeah, I forgot. 70 degree. So there's 4 conditions to be reference angle. The terminal side has to share with the original angle. The other side of the angle must be x-axis. The reference angle has to be less than 90 degree, and it's always positive. Reference angles are never negative. Okay, so that's how we get reference angle if you walk clockwise. But if you get the same thing if you walk counterclockwise, depending on where your position is. If you have anything on the first quadrant, that's your reference angle. If you have anything on the fourth quadrant, you just have to subtract from 360. If you have anything on the second quadrant, you have to subtract from 180. And if you have anything on the third quadrant, you have to subtract from, you have to add, no, you have to subtract 180 from the given angle. So here, we are subtracting 180 from the given angle 250. So if it's more than 180, you subtract 180. If it's more than 180 your angle, then you have to subtract 180 from the angle. Okay, so this is quadrant 1, right? This is quadrant 2. Any angle in quadrant 1 is the reference angle themselves. Reference angle and the angle themselves are same. Doesn't change anything. Any angle in the second quadrant that is less than 180 degree. It's less than 180 degree, so you're going to subtract your angle from 180 degree. Any angle on the third quadrant, it's more than 180 degree, so you take your angle and subtract 180 from that. That would be the reference angle. Because it's more than 180. So subtract 180 from your angle. If it's less than 180, subtract your angle from 180. And then if it's between 270 and 360, you subtract from 360. So any angle on the fourth quadrant, you subtract that angle. Come on, change. You take 360 and subtract your angle. That's your reference angle for fourth quadrant. So in 2, you subtract from 180. In 3, you subtract 180 from your angle. Okay, now all these angles you're talking about, they have two types of measurement. One is called degree measurement and one is called radian measurement. They are same, they tell us same information, but in different way. For example, inches versus meters. 1 meter and centimeter, meter, centimeter, inches, foot, yard, they all give us some measurement, but in different way. So degree and radian, they give us the measurement of the angle differently. The amount of rotation from the initial side to the terminal side determines the measurement of an angle. So basically, they are saying where you're starting and where you're ending. That tells us the measurement of our angle. One way to measure this angle is in radian. 1 radian is the measurement of central angle of a circle that intercepts an arc equal in length. Forget it. Da, 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 da. Ignore all the details. The relationship between radians and degree. 1 degree is pi over 180 degrees. So if you want to convert degree to radian, the conversion factor is pi over 180. For example, if you have 30 degree and you want to convert this into radian, you multiply your 30 degree by 180 degree on the bottom, pi on the top. So the degrees cancel out, the zeros cancel out, and 3 goes to 18 6 times. So 30 degree is same as pi over 6 radians. So if you want to convert degree to radian, you have to divide by a degree. And if you want to convert from radian to degree, then you have to divide by a radian. For example, let's say you have pi over 2 radian, and you have no idea where its location or how much is this. So you can convert this into degree. So you put pi on the bottom and 180 degree on the top. Why? Because our goal is to cancel the pi's. Pi gives us radians. So if you cancel the pi's, there'll be no more radians. Now 2 goes to 180 90 times. So answer is 90 degree. The symbol on the top, the power, 0 power, is called degree. 90 degree. Okay. If you want to go from degree to radian, you have to cancel the degree. So you have to divide by 180 degrees. If you want to go from radian to degree, you have to multiply by 180 over pi because radian must be cancelled out. And this is the first question in the final exam. Convert one from another. They either give you the degree, you have to convert into radian, or they'll give you radian, you have to find the degree. The final. Pi over 6 radians. Degrees. And then you have 30 divided by 180. 30 goes to 186 times. It looks like 0 power, but the 0 power is going to be. Okay. What is confusing? I'm clear. Like to play. That's how you convert. For example, 1 foot is how many inches? So if I give you 2 foot, how many inches you have? How do you know? See, you multiply them. Same thing here. If you want to go from one conversion to another conversion, it is the multiply conversion factor. Let's just have examples. More examples to make things clearer. Convert each degree into radian. Okay, if this is confusing, then let me erase all these things, okay? Forget about all this. These are the information you need to convert. So let me do the first one. We have, actually, let me do the third one. Second one. One more slide. I erased them, so ignore. These are the only thing you need to know. I will just show you example how to use this. But if those examples make you confused, forget it. We're going to do examples here. Let's say 30 degree and you have to convert into radians. So we are given 30 degree. Come on. And if you want to convert into radian, our answer should have a pi in it because pi means radian. Now, what can you multiply by so that the degree will cancel out? 180. You have to divide by 180 degree, and every 180 degree means 1 pi. 1 pi is 180 degree. So this is a conversion factor, like multiplying 2 by 12 to go from inches to foot. Same thing here, go from degree to radian. You need to cancel out the degrees so that the result is radian. So degree cancel out. And now 30 divided by 180, how much we get? 6. So we get 6 on the denominator. So on numerator, we didn't touch, it's pi. The denominator becomes 6. So 30 degree and pi over 6 are the same thing. One in written in degree mode, one is written in radian mode. So we know 30 degrees in the first quadrant. This is 30 degree. We can see it clearly. But if I tell you the radian, you don't see it, right? Because we're not used to it radian. So anytime you see radian and you want to find out what's the degree we have, we can simply convert the other way.
So would that be read as pi over 6?
Pi over 6 radian.
6 radian.
No, it's pi over 6. 6 pi is 6 times pi. It's pi over 6 radians. Means 180 divided by 6. That pi is 180. This one. Pi over 6 radian. This angle is 30 degree and also pi over 6 radian. Okay. Negative 135. So negative means you're going downward. So here. We know the position for 135 degrees here, but somehow you want to know its radian measurement. So how are you going to do? You take 135 degree and you multiply by what? Pi over 180 degree. So degrees cancel out, no more degrees. And we know we cannot divide 135 and 180, right? But we can simplify. What number, by what number we can divide both 135 and 180? 5. How many terms we have here? 5 goes to 13 twice, right? We left with 3. So we have 35. 5 goes to 35 how many times? 27. And 5 goes to 18 3 times. We left with 30. So this is 6. Can you read this more? By what? Can you do anything more than 3? 9. 9 goes to 27 how many times? 3. 9 goes to 36 how many times? 4. So what is our final answer? How'd you get 12? No, the position for 3 is on the numerator. The position for 4 is on the denominator. We have negative 3 pi on the top and 4 is on the bottom. The positive, negative doesn't matter. If you want to convert any angle, just multiply by degree on the bottom, pi on the top. And to 29 degree using calculator. How much is 29 degree in radian? So we multiply by what? Pi by 180 degree. Degrees cancel out. So we left with 29 pi over 180. Now punch this in the calculator and it will tell you the answer. 0.5 what? 061, and it says round to nearest hundredth. 100 means how many places? 2. So 0.51 radian. The symbol for radian is RAD, and the symbol for degree is DEG. So degree is DEG, that's the first 3 digit. Yeah. This is degree, and this is radian. You don't have to write entire degree. You can simply write DEG, we already know it's degree. Okay, now the other way around. Convert each angle from radian to degree. So we have pi over 3 radian. And since you want to cancel the radian, you have to divide by what? Divide by pi, and each pi is 180 degree. Pi cancel out. 3 goes to 180 60 times. So answer is 60 degree. Who would like to try the next one? Negative 5 pi over 3 radian. (180 over pi). What happened to the pi's? They cancel out. And 3 goes to 180 how many times? 60. So you have negative 5 and 60 on the numerator. Negative 300 degree. 5 times 60. After the cancellation, you have 60, but from before, you already have -5. So Fabia, would you like to try the last one? We have 5 pi over 9. Mm-hmm. Mm-hmm. 20. So 5 and 20 gives us how many? 100 degree. Simple, right? So C green, means it will be in the exam. Okay, now quadrantal angle. It means either the x-axis or y-axis. Which angles we have on the x-axis or on the y-axis? We call them quadrantal angles. For example, on the positive x-axis, where you start your journey, we have 0 degree. So 0 degree is a quadrantal angle. Then on the positive y-axis, we have a 90 degree. So 90 degree is a quadrantal angle. Now 90 degree is same as pi over 2 radians. If you don't believe me, you can convert 90 degree into radians. You'll see it's pi over 2 degree. If you are on the negative x-axis, then starting from 0 degree to negative x-axis, the total angle is 180 degree. So 180 degree is another quadrantal angle. And 180 degree is same as pi radian. Then starting from the first angle from 0 degree, if you walk all the way to the negative part of the y-axis, we have 270 angle total because 90 plus 90 plus 90 is 390s. That gives us 270 degree. So 270 degree is a quadrantal angle, and this is same as 3 pi over 2 radians. And then once you start walking, if you cross the entire xy plane, the total angle we have in the entire xy plane is 360 degree. So 360 degree is another quadrantal angle, and 360 degree is same as 2 pi radians. So you start from 0 degree, 90, 180, 270, and 360. For every xy length, x-axis or y-axis, we keep adding 90 degrees. And 90 degrees means pi over 2. So if you keep adding pi over 2 for every length of x-axis or y-axis, the total we get 2 pi. We're learning so many angles. First, we learned what is a normal angle. Then we learned what is a reference angle. Then we learned what is a quadrantal angle. And now we have another type, coterminal angle. Coterminal angles are two angles in standard position that they have the same terminal side. So coterminal has two conditions. The initial side and the terminal side must be same. For example, if you have an angle here, let's say theta, its coterminal angle we have to have the initial side and the terminal side. So the other portion is the coterminal angle. This is one possibility. Another possibility is that you can start from the initial side and then you walk all the way and then you stop at the terminal side. Oh man. And you stop at the terminal side. This is another coterminal angle. It doesn't matter how many rounds you take, coterminal angle has only two conditions. The initial side and the terminal side must be same. How you're walking, how many degrees you have, it doesn't matter.
So terminal angle always gonna be greater.
Look, if you take the red coterminal angle, so it starts from here and it ends at here, you have to walk clockwise, it's less than 60,
Less than 50.
less than 60.
It's not gonna be negative.
It is negative. So coterminal angle could be positive, could be negative, could be less than 60, could be more than 60, could be less than 60, could be more than 60. Even having the condition, there are only two conditions. The initial side and the terminal side, they must be same as the original. Which is the same spot.
But it, that actually shows us two green and blue.
If you want, you can have more. For example, you can start from the original and then you can walk backward, keep walking, and then you can stop here. This is another coterminal angle. Not specifically this topic, but we need this topic to move on to the next topic. So you wonder, why do you care about coterminal angle? Because why? Why do you care? We'll learn later why do you care. So the condition for coterminal angle is that the initial side means the positive x-axis must touch and the terminal side of the angle. So the initial side and the terminal side must be same. And then how many ways you walk, it doesn't matter. How you walk, the direction, it doesn't matter. Nothing matters as long as you have the initial side and the terminal sides are same. So how do you find coterminal angles? Oh, we care about coterminal angles because for negative angles, they are not standard. So anytime you deal with negative angle, we want to get positive angle. So use coterminal angle to get the positive angle of the negative angle. We don't like negative, right? Negativity in our life, we don't like it. So anytime you see negative, you have to make it positive. And to make it positive, coterminal angle is the angle we use. So to find coterminal angle, to find positive coterminal angle, and any multiple of 360 degree if you're given degree, or at 2 pi if you're given the radian volt. For example, if let's say you're given an angle negative 30 degree. So negative 30 degree is here. We don't like negative, so we want to get its positive part. So what you do is you take this negative 30 degree and you add 360 degree. It means you take one circle. So you end up getting positive 330 degree. So this negative 30 degree is same as you have positive 330 degree. Okay. So if you want to get a positive angle from a negative angle, always add 360 degree. If you're given the degree mode. If you're given the radian mode, then you add 2 pi. And then to find coterminal angle from bigger than 360 to smaller than 360. For example, let's say you're given an angle 410. We have no idea how much is 410, but we can have an estimate. Its coterminal angle will be 410 minus 360. So 36 and 41, how much we have? 1 minus 6 is 5, 50 degree, right? Its coterminal angle is 50 degree. And we know why it's 50 degree. It's in the first quadrant. So 410 starts from here, go all the way here. Then this red, when you walk twice, this is 410 degree. It's confusing to work with 410 degree. So we can get the coterminal to make our life easier. It's 50 degree. Suppose they are saying we have 50 degree in the first quadrant. Okay, now to find positive coterminal angle from negative angles, we add 360. You already know we did this here. And then to find negative coterminal angle, subtract any multiples of 360 from the given angle. For example, if you have you want to find negative coterminal angle. So if you want to find what would be the negative coterminal angle for 410 degree, you are going to keep subtracting 360. When you subtract once, you get 50 degree. Then you subtract one more time, you get how much? Negative 0 minus 0 is 0, 6 minus 5 is 1, and then you have 2. This is negative coterminal angle. So depending on what you need, either you add 360 or keep adding 360 until you get what you want, or you keep subtracting 360 or the multiples of 360 until you get what you want. So coterminal works with 360 degree, which is same as 2 pi. If you want a coterminal angle, either add 360 or subtract 360. It means either add 2 pi or subtract 2 pi. That's it.
What, first example?
That first example.
Second.
The second one, so it says to find coterminal angles from bigger than 360 to smaller than 360, you subtract 360. The third angle from a negative angle, if you want to get 360, you have to get coterminal, like the first example. If the angle is negative and you have to get a positive version, you add 360.
So this third example here is actually the fourth.
The third one is the first one. To find positive coterminal angle from a negative angle. So negative angle is 10.
The fourth one is this one last.
It says from any angle, it's going to find a negative coterminal angle. Keep subtracting 360 until you get the negative angle you're looking for. So when I subtracted 360 once, I still have positive angle, but I'm looking for a negative angle. So you have to subtract 360 one more time. And then we get the negative angle, we stop. We want the negative angle, we got it. If you want, you can keep subtracting 360 to get another negative angle. The coterminal has only one thing, either add 360 or subtract 360. You keep adding them or keep subtracting them. Okay, so I believe these are all the angles we need to know. The normal angle, reference angle, coterminal angle, quadrantal angle. No more angle, 4 types of angle. Okay, one example from your homework. Determine which angles in the figure are coterminal angles with the angle A. So let me highlight the angle A. This is the angle A. Okay. Now we are given three angles, B, C, D. Which of these angles is the coterminal angle of A? Definitely C, because C is starting from here and it goes, oops, it goes all the way to the terminal side. So definitely C. Which one? B. Okay. B starts from here and it goes all the way to the terminal side. Definitely, sorry, B. Definitely B. Now, how about D? Why not? What's wrong with D? Good job. Cannot be D because D doesn't have the same terminal side. So D is the only graph that shares the initial side, but it doesn't share the terminal side. Cannot be D. So you see, coterminal angle could be anything. It doesn't matter how many times you ground your entire circle. As long as you end up on the terminal side, it's a coterminal angle. Okay, so yep, B and C are the coterminal. Okay, now here comes the actual trigonometry. Sine, cosine. We have 6 trigonometric functions. Sine, represented by SIN, it's not sin, it's called sine. Cosine, we represented by COS, cos. Tangent, we represented by TAN, tan. Or we don't call tan, we call it tangent. And then we have cosecant, which is represented by CSC. Then we have a secant. We use SEC to represent that. And the last one is cotangent. We use COT to represent that. So if you see written this, we read it as sine of x. It's not sin x, it's sine of x. If you see this, it means cosine of x. It's not cos of x, it's cosine of x. So when you speak, you have to use the entire name, but when you write, you just use the 3 letters. Tan of x, we don't say tan of x, we say tangent of x. So verbally speak the entire name, but when you write, only use 3 letters. Now they have a relationship among themselves. The sine is the inverse of cosecant. So not inverse, reciprocal. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. Similarly, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So sine goes with cosecant. Cosine goes with secant. And tangent goes with cotangent. They have this relationship. Now we use trigonometry a lot in a right triangle. So based on the right triangle, all these trig functions, they have a relationship with the right triangle, the length of the right triangle. The sine of x, the sine of an angle is the ratio of the opposite side of the angle divided by the hypotenuse of your triangle. So if your angle is here, its opposite side is whatever you have straight across from the angle. The adjacent side is whatever you have the initial side. And the hypotenuse is always the longest length of a triangle. So if you want to find sine of your angle, you take the opposite length of that angle and you divide it by hypotenuse. If you want to take cosine of the angle, you take the initial side of your angle, which is called adjacent, and you divide it by the hypotenuse of your angle, hypotenuse of the right triangle. And if you want to find the tangent of the angle, you take the opposite side of your angle, you divide it by the adjacent side of your angle. Mm-hmm. The length, how much length you have for that side. You take that length and you divide it by how much you have on your side length. Now, if you know sine, cosine, tangent, you know the other three. Because you just flip them, they become the other three. So that means all you have to remember is the first three things. How to sine, what is cosine, what is tangent. So I don't know who invented it, but some people invented a phrase called staccato. It means sine is opposite of our hypotenuse. Cosine is adjacent of our hypotenuse. And tangent is opposite of our adjacent. This is a phrase people use to remember the relationship between sine, cosine, tangent, and the triangle, the right triangle. And this is my favorite character, Anya. Did you guys watch Spy X Family? Huh? Only season 1? Season 1 is much better than season 2. In season 2, I hated that. They basically talked about the sister and his brother, the sister and her brother, how they have a relationship dilemma, like how much the brother loves the sister and what he does. I hated that. Season 1 was fun. Season 2, not fun. And they have season 3. Did you know? They already completed season 3. I forgot what was season 3 about. But yeah. But I found the season 1 was the best. Okay, I love that Spy X Family. And I love her character the most. Yeah, I have more information. Yep, I have more information. So you keep writing them down and let me take your attendance. And also I have your exam if you are absent yesterday. Hmm? Okay. Oh man. Rizia here, Hector G here, Marco here, Joanna here, Gabriela M here, Neva absent, Hector B absent, Faria absent, Arif absent, Malvina here, Gabriela D here, Mia here, Diego here, Tristan absent, Prabzat here, Rachel here, Julia here, Fabia here, Angela here, Isabella here, Steven here, Brian absent, Shihan absent, Kimberly here. Oh man, my head is hurting so much. Are you guys done with the left page? Then this is the unit circle we are going to use. Oh, I forgot to post the solution. But yeah, I'll put the solution later. Easier. Okay. Hello. I already explained Sakata to you. Please remember this Sakata. What is the relationship between the right triangle and the trig function? And now comes the unit circle. Unit circle is a circle that has radius 1. So every way you go from the center to the circumference of your circle, every length is 1 unit. That's why it's called unit circle. Unit is 1. Every point of the unit circle corresponds to an angle in standard position. So every angle you have to start from the 0 degree, positive x-axis, and then you have to go counterclockwise to get to your angle, standard position. Now, this is a picture of the unit circle. The first quadrant, we have 0 degree, 30 degree, 45, 60, and 90 degree. So 1, 2, 3, 4, 5. There are 5 angles we have in the first quadrant. And all the angles are positive. So every length of the triangle we have, they are positive. For example, our x-axis is positive, also y is equal to 2. So all these numbers you see, they are positive. Now I forgot to mention something. I should have mentioned it earlier. Every time you see sine of an angle, it represents the y value of your quadrant. Every time you see cosine of an angle, it represents the x value of your quadrant. So how I remember this is cos is x. They both have x count. Cos x. Now sine I and y, they're both I here. So that's why I remember which one is what. Sine y cos x. So observe the sound and you'll not forget the position. So for 30 degree here, from 0 degree to 30 degree for this angle, if you're looking for sine of 30 degree, it's the y value of your quadrant. The y value here is 1/2. And if you're looking for cosine 30 degree, cos is the x value. So the x value here is √3/2. So that's how we use those points. Every x value represents the cosine of the angle. Every y value represents the sine of that angle. And unit circle has only sine and cosine. Then you may wonder, how can we get the other 4 angles, other 3 functions? Well, tangent, did I tell you here? Tangent is 1/cotangent, and it's also sine/cosine. Tangent has 2 information. One is the reciprocal of the cotangent, and the other is if you divide y by x, sine by cosine, then you get tangent. So in the unit circle, as long as you know your sine and cosine, you can get all the other 4 angles, other 4 trig functions. That's why unit circle doesn't give us all 6. The information about all 6 functions, they give us only 2 main information, x value and the y value, means sine and cosine. Cosine over sine. So in the unit circle, if you want to use the unit circle, if you want to make your life easier, all you have to do is remember only the first quadrant. You may wonder, why only the first quadrant? We have so many information in the entire unit circle. So why only first quadrant will tell us everything? Well, observe something cool. This 30 degree here, we have √3/2 and 1/2. Look at here. The same number, √3/2 and 1/2, just the x value is negative. Because x is negative on the second quadrant. So whatever angle we have here is the same angle here, just all the x values are negative. The first quadrant repeats on the second quadrant, changing the sign for x values. Now observe this one and this one. On the third quadrant, our x is negative, our y is negative. So every angle we have here, all those numbers, they're exactly same numbers here. The difference is all the x is negative, all the y is also negative. The first quadrant also represents the third quadrant by changing sign for all of them, all the numbers. And if you observe this one and this one, they're also same thing. The only difference is sign is x value is positive here, The y is negative here. So every x value will stay positive, every y value will turn into negative. But this is the exact same information on the first quadrant. So if you know your first quadrant, you can always replicate the other three quadrants. That's why we just have to remember the information on the first quadrant, the 5 angles: 0, 30, 45, 60, and 90. And even we have to remember 0, because look at the position of the 0. We have this unit circle, means every length is 1 unit. So this x value is 1 and our y value is 0, because we are not moving up or down. At this point here, the 90 degree, this is y1, y-axis, y1, and our x is 0. So y value is 0, y value is 1, x value is 0. Now here, to 180 degree, but this is the negative x-axis. So it's -1 for x and 0 for y, because we are not moving up or down. Lastly here, on this side, we have 270 degree, but this is -y. This is -1 for y and 0 for x, because we are not moving left or right. That's on the y-axis. So every x-axis, oops. If this is your center 0, then this is x equals +1, this is x equals -1. For the y direction, if you go upward, this is y equals +1, and this is y equals -1. So every length, 0 degree, 90 degree, 180 degree, 270 degree, and when you come back to 360 degree, they all have either 1 or -1 for x and y. When x is 1, y must be 0. When y is 1, x must be 0. So it's always 1 or 0. If one of them is 1, the other one must be 0. If one of them is -1, the other one must be 0. You cannot have any other number on the axis except 1, -1, and 0. That means you don't even have to remember the 0 quadrant, the 0 degree, and 90 degree. You just have to remember the first three angles: 30 degree, 45 degree, and 60. If we can remember these three angles, replicate it 3 times, you get the entire unit circle. And we can remember all these angles. So this is 30 degree from the positive x-axis. This is 30 degree from the negative x-axis. So if you have to get the standard angle, you go from 180 minus 30, you get 150. From 0 degree to here. Now if you look at this 45 degree is on the positive x-axis. For example, here, from here to here, we have 45 degree. So it replicates on the second quadrant. From here to here, we have a -45 degree. If you want to get the standard angle, you subtract 45 degree from 180 degree, you get this positive angle, which is what? 135 degree. Now this one, from standard position, this is 60 degree. So when you replicate from the negative x-axis to here, this will be -60 degree. So here to get the positive angle, you just take 180 and subtract this, you get the positive angle. Or you don't have to memorize anything. If you know how to derive, memorization is not needed. Okay. Now the tricks to remember all this information. Let me ignore all of this because I already told you everything. I told you all of this. So the main thing you to remember is the first quadrant. There are many tricks to remember the first quadrant. Trick number 1, the finger trick. So in the finger trick, how are you going to find all those x and y values. It's simple. You just take whatever angle you need. For example, let's say I want 45 degrees. I want to know 45 degrees. So if you want to find the 45 degree, the format will be square root of something divided by 2. Every number here you have, denominator is 2. The numerator is square root. So you square root on the top, 2 on the bottom. And then how do you figure out what goes under the square root? Is this. If you're looking for 45 degrees, you count how many fingers you have on the left of 45 degrees, put that on the first square root, and you count how many fingers you have below your 45 degrees, put that under the second square root. So 2, square root 2 over 2, square root 2 over 2. That's the x-axis and the y-axis. And you can verify this here. Let's see what is 45 degrees. 3 for 45 degrees, square root of 2 over square root of 2. Now let's say you want to find 60 degrees. Now 60 degrees is the fourth finger. So on the left you have 1. So you put 1 here. Oops. We put 1 here. And below this second finger, we have 3 of them on the right. So 3 goes here. So it's basically 1 over 2 and square root of 3 over 2. Let's see. 1 over 2, square root of 3 over 2. Ta-da! So you don't have to memorize anything. Just look at the finger, and then you figure out what you have. Let's see and to find 90 degree. You don't have to find it because you already know. 90 degree is the y-axis. So y is 1, x is 0. But let's say you forgot that. So on the left of 90 degree, how many angles we have? 0. So 0 goes here. And on the right of your thumb, how many fingers do you have? 4 of them. So we have square root of 0, which is 0. And square root of 4 is 2. So it's 0, 1. So no memorization is needed if you just look at your fingers. Left on the first. The bottom will be your y. So this is one trick. And I found this is the coolest trick. Now using this trick, let's find these angles. So let me erase all this. Okay, 45 degree. Sine 45 degree. We don't need triangle. We use opposite one, use triangle. We don't need triangle here, just using our finger. So first of all, sine represent the y. What's the y value for 45 degree? So 45 degree is the third finger. The bottom represent y, the top represent x. So the bottom you have 2. So square root of 2 on the top, and denominator is always 2. The first one is x. The second one is the y. So top, the left represent x, the bottom represent y of your finger. The left represent x value, the bottom represent the y value. Okay, cosine 30 degree. So 0, 30, the second finger. So cos means x, means you're looking for the above, the top, the left. So we have 3 of them. So square root of 3 and denominator is always 2. 2, right? Okay, how about 0 degree? Sine 0. Yes. Sine means y. So 0 degrees here. Our x value is 1. How much is the y value? 0. So sine 0 is 0. Or if you want to use your finger. So 0 is the first finger. And you're looking for sine means bottom. How many fingers you have on the bottom of the last finger? 0. How about cosine 90 degree? Cos is the x. 90 degree means the thumb. And cos means left. How many fingers you have on the left of your thumb? How many fingers you have on the left of the thumb? 0. Sine 30 is how much? 1/2. So 30 degree is the second finger. Sine means y. Y means the right. So on the right of your second finger, you have only one of them. So it's 1 and denominator is always 2. See here, this is 30 degree. And you're looking for y. Y means bottom. We have only one finger on the bottom. So it's 1/2. And how about the last one, 60? 1/2. So 60 degrees here. Cos means x. X means left. So on the left, you have only one finger. And denominator is always 2. Okay? Now there is a second trick to remember your first quadrant. The trick is make a chart, make a table. And when you make a table, you only make the first line for sine. The rest will follow automatically. So you do the same thing as the finger. The denominators are always 2 and all the numerators are square roots. And then what you do is you write down all the numbers starting from 0. 0, 1, 2, 3, 4. And let's simplify. 0 divided by 2 is 0. Square root of 1 is 1. 1/2. And square root of 2/2, it doesn't change. Square root of 3/2, it doesn't change. And square root of 4 is 2. And 2 divided by 2 is 1. So all of these are for sine. Sine 0 degree is 0. Sine 30 degree is 1/2. Sine 45 degree is √2/2. You may wonder, why did you get √2/2? Well, this one, if you have, never mind, √2/2. And then sine 60 degrees is √3/2. Sine 90 degrees is 1. So you just find out all the numbers, the 5 angles for sine. For cosine, you do something amazing. You write this down again, but in reverse direction. 0, 1/2, √2/2, √3/2, and 1. That's it. Sine is same as cosine. So cosine is same as sine, but the position will change. And for tangent, just divide sine by cosine. For example, our sine is 0, cosine is 1, so we get 0 here. So tangent 0 degree is 0. We have 1/2 divided by √3/2. You do keep change flip thingy. It turns out to be 1/√3. This one is root 2 over 2 divided by root 2 over 2. They are the same thing, so you get 1. This one sine is root 3 over 2. You divide by 1/2. You do keep change flip. The result is square root of 3. The last one, we have 1/2 and you are dividing by 0. Can you divide by 0? The tangent 90 degree doesn't exist. You see, this is the first quadrant of your unit circle. So method 1, we use finger. Method 2, we use table. And then there is one last method. It's a triangle, Sakatwa. You use Sakatwa to remember the three angles. The downside about Sakatwa is that it only gives you three angles. It doesn't give you 0 degree or 90 degree. It only gives you 30, 60, or 40, 45. These three angles. Are you guys done copying the left page? Okay. Let me know when you're done. So I'm going to flip it. And then I'm going to give you 5 minutes break after copying the next 2 slides. So 1/2 divided by root 3 over 2. You keep the first fraction, change the division into multiplication, and you flip the right fraction. So you keep your 1/2 times 2 over square root of 3. 2 to cancel out, you end up getting 1 over square root of 3. So for now, your job is to fill out the rest. Once you have your sine, cosine, tangent, you have everything. And then fill out this thing, whatever we have. I'm going to give you 5 to 10 minutes break. Once you're done copying this, enjoy. Take a break. Relax your brain. You can gossip around. So fill out the left box. All the information is empty. Fill that out. I was confused what he was doing. Then I realized what I was doing. Okay. So two special triangles. Before that, let me fill out the table. Who has the answer for cosecant?
Candy.
Mm-hmm.
And over.
Do you guys have the same thing? I'm trusting him. Okay, secant. Who has the answer for secant? Gabriela. Mm-hmm. 3/2. 2/2. 1. I think 60° 1 doesn't make sense. Mm-hmm.
Yes, two, sorry.
2. And are you sure 30° is 3/2 or 2/3? It should be 2/3. Column. 2/3. And then 90°. 1/0, 0/1. Yep. Do you know how did I know you got me wrong the number? Mm-hmm. Secant and cosecant are same as sine and cosine. They are the same number in reverse direction. So whatever you have here, that goes there. The second number goes here. Third number stays same. Fourth number becomes second. The last number becomes first. It's the reverse direction. So if you know one of them, you know the rest.
Oh, so it's DNA for the last one.
No, the last one is 0. It's DNA because it's 1/0.
Right.
That's its DNA. So here you flip it, it's 0/1, which is 0. It is 0.
Oh.
It's not DNA, it's DNA when you 1/0. So when you flip, it becomes 0/1. 0/1 is 0, not DNA. So 0/1 is 0. Okay, now who has the last row? The last row. Marco.
The DNA.
DNA. Mm-hmm.
The over.
Root 3/2. Are you sure root 3/2? Let's see.
Yeah.
No.
It'd be
Tangent 1/√3. For tangent is
root three.
and also I know this. I had my doubt because you see when you divide these two, you're supposed to get root 3, not 2/√3 or 3/2. How about the last one, the next one? The first one, the middle one is 1, right? 1/√3. 0. Okay, so see, if you know the sine and cosine rule, you know the rest. So this is one method of finding the first quadrants for all 6 trig functions. Now the last trick is the 2 triangles, but unfortunately these are only for 3 angles, 30, 45, and 60. How do you use them? You use the Socatua. So sine is opposite of the angle divided by the hypotenuse. So if you want to find 30 degree has opposite 1 and its hypotenuse is 2. So it's 1/2. But you have to remember these triangles, the length of each side. So how do you remember the length of each side? 30 degree is the smallest angle in 330, 60, 90. So we use the smallest number 1 to represent the smallest angle. Then the largest angle is 90. So we use the next number to represent the largest angle. The smallest angle is 1. Largest angle has length 2. And now if you add them 1 and 2, you get 3. But this 3 goes inside your square root. So the opposite of 60 degree is square root of 3. So smallest angle gets 1. Largest angle gets opposite 2. You add them, put it under the square root. That's the opposite for the middle angle, which is 60. That's how you can remember the 3 lengths, the 3 sides of a triangle. 45 degree also has the same concept. We have double 45 degree. And between 45 and 90, 45 is the smallest one. So opposite of each 45 degree has length 1, the smallest number. Smallest angle has smallest number. And if we add them, we get 1 plus 1, 2. Put it under the radical for the other angle, 90 degree. The right triangle, so use Pythagorean theorem. So that's how you can remember. Smallest angle has the opposite 1. For 30, 60, 90, we have 3 types of angle. So largest angle gets 2. And the middle one, you add 1 plus 2, take the square root. For 45, there's only 2 angles, 45 and 90. So since we have double 45, we have double 1. And if you add the 1, you get 2. Put it the radical, it becomes the third side. Now, if you can remember, you must actually should remember these 2 triangles, because if you use these 2 triangles, you don't have to think about unit circle. You can use these triangles to anywhere in unit circle, and you can get the length for each. You can get the value for each trig function. Okay, so using these 2 triangles, what is sine 45? 45 is here. So I can take this 25 or Lec 25, it doesn't matter if it is 50. Opposite is 1. So sine is what? Opposite over. So SOH, right? Opposite over hypotenuse. So 1 over square. So 1 over square root of 2, because this is opposite, this is hypotenuse. Now, unit circle, instead of using radical 2 on the bottom, it rationalized. So this is same as square root of 2 over 2. They are the same number. So you can use 1 over root 2 or square root of 2 over 2. The correct version is square root of 2 over 2, because we don't want the radical in the denominator. But if you keep the radical in the denominator, we don't care anyway. Cosine 60 degrees. Square root of 2, you're missing something. So cosine is adjacent of our hypotenuse, right? So 60 degrees here. Which side is adjacent? This one side is adjacent. So 1. And our hypotenuse is 2. 1 over 2. Cosine, remember. So ca means cosine is adjacent of our hypotenuse. Our 60 degrees here. The 60 degree has adjacent is like 1 and hypotenuse is 2. Adjacent of our hypotenuse is 1 over 2. Or you can use your finger. 60 degrees is the fourth angle, the index. Cos, is it x or y? X. X means the left. So how many fingers you have on the left? 1. And denominator is? 1 over 2. So you can use the special triangle or you can use your finger. And then the rest are same, okay? So let me skip through all these things. But actually we have more functions, so let's do it. Secant 30 degrees. So cosine and secant are reciprocal. Cosine is adjacent over hypotenuse. Secant must be hypotenuse over adjacent. So it's hypotenuse and adjacent. 30 degrees here. Hypotenuse is 2. Oh, it's root 3. So it's 2 over root 3. Not 2. Secant, right? Okay, ka. Ka means cosine is adjacent over hypotenuse. That means secant must be opposite. Hypotenuse over adjacent. So from 30 degree, our hypotenuse is 2, adjacent is root 3. So it's 2 over root 3. You just have to remember these 3. Sine, cosine, tangent. Flip them, we get the other 3 functions. Okay, how about cotangent? 1 over square root of 3. Okay, let's see. Let me erase this. 60 degree is here. Cotangent is or adjacent over adjacent over opposite. So adjacent is 1 and opposite is root 3. So 1 over root 3. Gabriela, Dada Gabriela, you look confused. What happened? To process. Pick your favorite method. Which one? Finger, triangle, or table? Pick one favorite. Finger. Stick with that. Forget about everything else. Stick with your finger. And then nothing else matters anymore to you. Okay? Now, using your finger, what do you think will be cosine 45 degree? Remember, cos. Denominator is always 2. How about the numerator? Not only 2, square root of 2. Numerator always a square root, and then you simplify. So square root of 2, we cannot simplify, we can keep. Right. Can you do cosecant 60? First find sine, because sine and cosecant, they're reciprocal. What is sine 60? Sine. So y 60, y is the bottom, right? Y is the bottom. So sine is radical 3/2. So cosecant will be 2/radical 3. Right? (45) is in the middle one, right? So above we have 2, below we have 2. Cos means above x. We have 2 under the radical. So 0, 30. Middle is the 45. It is the middle finger. Half of 45. This is 90. Cos is the x. X means above.
Sine and cosine.
The same. Because they're in the middle. See, when you have middle finger, you have 2 above, 2 below. So x and y, they're same. Doesn't change. Okay, so now we know all this information, how to find sine, cosine, tangent, or the other three, and their angles and everything. And now we're going to find angles, but based on quadrants. So let me draw my quadrants. Quadrant 1, 2, 3, and 4. And again, what is sine x of the y? Sine x of the y? Sine y and cos x. Now, in this example A, it says if sine is bigger than 0. What does bigger than 0 mean? Positive. And cosine is also bigger than 0, means positive. So look at the quadrant where your y is positive, also x is positive. Quadrant number 1. If x is positive, ay is positive. So our angle, it will lie on the first quadrant. It doesn't matter what angle they give you, as long as they both are positive, it has to be in the first quadrant. So x is here in the first quadrant. Now let me draw again my quadrants again. Who'd like to try B? Melvina. How do you know? Y negative, x negative. So on which quadrant both of them are negative? Fourth quadrant. Oh, well, yeah, because x is positive in the fourth. Here. quadrant number 3. Cool, right? They didn't tell us anything about the angle, but just based on the sign, we can already figure out the position of our angle. Have your agility to the next one? What is cosecant? Cosecant is related to which function? Sine. So it's 1 over y. And bigger than 0 means positive. Okay, tangent. What is tangent? In terms of x and y, because you're working with quadrants, you need x and y. Sine over cosine. And what is sine y and cos x? So this is negative. So what information we have? 1 over y is positive. So what is y? Positive or negative? Positive. So this information is telling you that y is positive, but x is negative. They're telling us indirectly. Yep. Y is positive, x is negative. Our x is lying here. Good. Whatever helps you to visualize the scenario. So this is from the homework. In the homework, they'll ask you specify the quadrant. So you just have to specify the quadrant. How do you know? You figure them out now. This is not being the quiz directly, this type of question. The quiz will have, or the exam will have, think that you need this information. The last one. Secant and cotangent. Any volunteer? Marco. 1 over x. Positive. That means x is positive. Cotangent is x over y. But you already know x is positive. That means y must be negative. Our x is positive, y is negative, x is lying here. So how do you like trigonometry so far? Secant. Secant is the reciprocal of cosine. So cos is what? X. So it says secant is positive. Means x is positive. And the next one says cotangent is negative. But cotangent is cosine over sine. Means x over y. So if you already know your x is positive, that means y must be negative to get the negative. Okay. Now using this information, find the exact value of something. Find the exact value of the 5 trig functions. All trig functions based on the information given to us. So let's see, our quadrant is which one? Actually, let me make it a little bit to the right. I don't need that many things. Okay, tangent is negative. Which quadrant has tangent negative? It could be 4 or 3 because this is x over y. So either x is negative or y is negative. You get 2 choices, here or here. Oh, it could be also 2.
No, no. It could be only, actually, then it could be only 4 or 2. It could be both.
True. There are 2 candidates, either here or here. 2 choices, right? Now, cosine is 21 over 29. Is cosine positive or negative? Positive. So between second and fourth, which quadrant has positive x? Between 3 and 4, because 1 usually excluded because of the tangent. So tangent is telling us our angle is either on the second or on the fourth, because this is negative. Tangent. Tangent is negative in these 2 quadrants. This is telling us cosine is positive. Cos means x. X is negative here, x is positive here. So our angle is lying on the 4th quadrant here. So we have a triangle here. This angle here is x. Now, cosine is what over what? Adjacent over hypotenuse. So from this angle, which side is adjacent? The x-axis or the y-axis? X-axis. So this is 21. And how much is our hypotenuse? 29. So this is 29, this is 21, because 21 is adjacent and hypotenuse is always the longest side. So what is missing? The opposite. Opposite. Is there any way we can find the opposite side? How? We have a square plus b square equals c square. Let's say this is a, this is b, and this is c. C is always the hypotenuse. We are looking for b. So b square is c square minus a square. Right? So b is square root of c square minus a square. The question is, how much is the c? 29. So this is 29 square. And how much is the a? 21 square. So use a calculator and find out the final answer. How much is square root of 29 square minus 21 square? These are squares. Do you already have the number? 20. Okay. Now comes my second question. How did you do it? See, at the end you subtracted, right? So I subtracted before and then substitute the number. Whichever is easier for you. Okay, so we found, let me draw it again. This time nicely inside one page. So let me do the graph again. We have a triangle here. This side is 21. This side is 29. And this side is 20. My question is 21 positive or negative? Positive because positive x. How about 20? Is it positive or negative? Why negative? Because it's y, it's negative. So we have actually a negative 20. How about the 29? It's always positive. Hypotenuse can never be negative. Okay, so now we can find out all 5 trig functions. Sine of the x. This is our x. What is sine? What over what? Opposite over hypotenuse. So how much is sine here? Negative 20 over 29. Does it? And they only told us cosine, so you're going to skip cosine. But let me write it anyway. Cosine. 21 over 29 already given. And now let's find tangent. In terms of triangle, tangent is what over what? Opposite over adjacent. So what is the opposite here? Negative 20 over 29. Oh, adjacent. Sorry. 1. And once you have them, you can ignore that. You can ignore the triangle because that's going to tell you the other three. What is cosecant of x? It just flips sign, it becomes cosecant. They are reciprocal of one another. So just flip it.
So negative.
Negative because the y is negative here. Okay, then cosine gonna give us secant. What is secant? 29 over 21. It's opposite of whatever we have. And the last one, cotangent of x. Negative 21 over 20. That's it. That's how we use a triangle and staccato. Would you like to try one more before you go? Okay, second. We're gonna leave it for tomorrow. So tomorrow we have the negative belongs to either one of them. You can just put on the middle. One of them is negative. Which one doesn't matter? Bye bye. Have a good day, everyone. Don't forget to start doing your homework on trigonometry. You're going to enjoy them. See you all tomorrow. Bye bye.